Have you ever wondered how computers know exactly what to do whenever you click or type something? It's a marvel, isn't it? This magic is brought to life by the intricate art and science of programming. At the heart of every application, every game, and indeed every digital interaction lies a meticulously crafted code, instructing the computer on what to do and when. Now imagine a world where this code is chaotic, unmanageable, a tangled web of instructions. It's a programmer's nightmare, right? To avoid this, we have a hero in our story, and that is structured programming. It's the guiding light in the vast cosmos of coding, a beacon of order and efficiency. It's a principle that's widely embraced in the programming world, a key ingredient in the recipe for robust, reliable, and reusable code. So are you ready for an exciting journey into this fascinating realm? Let's unravel the mystery of structured programming together. Structured programming, in essence, is a logical way of programming. Allow me to break that down for you. Structured programming is like building a house. You wouldn't start by throwing all the materials into a pile and hoping for the best, right? Instead, you divide the construction into different stages, like laying the foundation, building the walls, and installing the roof. Each stage is crucial, manageable, and can be developed and tested separately. Similarly, in structured programming, we divide a program into smaller, manageable sections, often referred to as modules or procedures. Each module has a specific task, like calculating a result, sorting a list, or printing an output. This way, programmers can focus on one piece of the puzzle at a time, making it easier to understand, write, and debug the code. But these modules aren't standalone entities. They're like the pieces of a jigsaw puzzle. Individually, they might not make much sense, but when they're combined in the right way, they form the complete picture, or in this case, the complete program. Now you might be wondering, how are these modules combined? Well, they're linked together through a process called control flow. This is the order in which the modules or blocks of code are executed. It's like the blueprint of our house, showing how the different parts fit together. In structured programming, the control flow is managed using three types of structures: sequence, selection, and iteration. Sequence is the default control flow, where code is executed line by line. Selection allows decisions to be made using if-then-else conditions, and iteration allows certain parts of the code to be repeated using loops. So you see, structured programming isn't just about writing code. It's about organizing and structuring that code in a logical, understandable, and efficient way. Understanding structured programming is like learning the language of computers. It's about speaking in a way that both humans and machines can understand, turning complex ideas into simple, manageable tasks. It's the foundation upon which all modern programming is built. And by mastering it, you're well on your way to becoming a proficient programmer. Structured programming rests on three crucial pillars: sequence, selection, and iteration. These pillars form the bedrock upon which all well-structured programs are built. Let's start with the first pillar, sequence. This is the most straightforward of the three. In essence, it means executing instructions one after the other, in the order they are written. A simple example would be making a sandwich. You first take out the bread, then you spread the butter, add your filling, and finally, you put the second slice of bread on top. Each step follows the previous one in a sequential order, just like lines of code in a program. Next up, we have selection. This is where things get a bit more interesting. Selection allows us to make decisions based on certain conditions. It's like coming to a fork in the road and choosing which path to take based on a signpost. In programming, an if statement is a common example of selection. If a certain condition is met, we execute one block of code. If not, we might execute a different block of code or skip it altogether. Finally, we come to iteration, the third pillar of structured programming. Iteration is all about repetition. It allows us to repeat a section of code as many times as needed. Think of it like doing laundry. You don't wash each sock individually, right? Instead, you repeat the same washing process for the entire load. In programming, loops, such as for or while loops, embody this concept of iteration. In the world of programming, these three pillars, sequence, selection, and iteration, are the fundamental concepts that guide us in creating structured, logical, and efficient code. By understanding and skillfully applying these principles, we can create programs that not only work but also are easy to understand, modify, and debug. With these three pillars, we can construct complex and efficient programs. Structured programming isn't just a fancy term, it offers tangible benefits. Imagine a recipe book without a table of contents, or chapters, or even sections to differentiate appetizers from desserts. Sounds chaotic, right? That's what programming could be like without structured programming. It's the organizing principle that tames that chaos. One of the key benefits of structured programming is improved readability. This is like having a well-organized recipe book where each dish is clearly labeled, with ingredients and steps neatly laid out. In structured programming, code is broken down into smaller, more manageable pieces, often called modules or functions. This makes it easier to understand the overall flow of the program and to locate specific sections of code. It's like being able to go straight to the dessert section when you're craving something sweet. Another major advantage is the ease of debugging. Just like when you're trying to figure out why your soufflé collapsed, it's much easier to troubleshoot when you can isolate the problem. With structured programming, if one module malfunctions, you can focus on fixing that module without having to sift through the entire program. It's a bit like knowing that you probably messed up the egg whites, not the chocolate sauce. And let's not forget about efficient code reuse. This is like being able to use the same base recipe for multiple dishes. With structured programming, you can create a module that performs a specific task and then call upon that module whenever you need it. This not only saves time, but also ensures consistency. Just as using a master tomato sauce recipe ensures every pasta dish has the same delicious flavor. These benefits all come together to create better, more reliable software. It's like following a well-tested recipe to ensure that your dish turns out tasty every time. In the same way, structured programming leads to software that is more predictable, easier to maintain, and more robust. Structured programming is like the secret sauce that makes our software tasty and reliable. Structured programming has made a lasting impact on the world of programming. Its influence has been profound and far-reaching, shaping the way we approach software development today. In the early days of computing, programming was akin to a dark art, with programmers having to manually manage memory and juggle machine-specific instructions. But the advent of structured programming brought a breath of fresh air into this landscape. It introduced a higher level of abstraction, allowing programmers to focus more on the logic of the problem rather than the intricacies of the machine. Structured programming has been instrumental in the development of high-level languages. C, one of the most influential languages in history, was built on the principles of structured programming. It discarded the unwieldy go-to statements and instead favored control structures like if-else and loops. This made the code easier to read, understand, and debug. The legacy of structured programming can be seen in many modern languages like Python, Java, and JavaScript, which have inherited these control structures. The impact of structured programming extends beyond languages. It has made significant contributions to the field of software engineering. By promoting modularity and code reuse, it has made the process of software development more efficient. Complex software systems can now be broken down into manageable modules, each handling a specific task. This modularity makes it easier to maintain and modify the software over time. Furthermore, structured programming has paved the way for other programming paradigms like object-oriented programming and functional programming. These paradigms have borrowed concepts like control structures and modularity from structured programming and combined them with their own unique features. In conclusion, structured programming has revolutionized our approach to writing software. It has transformed programming from a cryptic craft into a logical and systematic discipline. It has given us the tools to tackle complex problems with greater clarity and efficiency. Structured programming has revolutionized our approach to writing software, making it an essential tool in every programmer's toolkit. So, we've taken a fascinating journey into the world of structured programming today. We started by admiring its allure, then dived into its definition, helping us to understand what it really is. We explored its three fundamental concepts: sequence, selection, and iteration, which are the building blocks of this approach. We also discussed the numerous benefits of structured programming, from making code easier to understand and debug to enhancing its modifiability. Finally, we examined the profound impact structured programming has had on the field of computer science, revolutionizing the way we write and understand code. All this information may seem a bit overwhelming, but remember, each concept is a piece of the puzzle that forms the complete picture of structured programming. Keep revisiting these ideas, practice coding, and you'll find that you're navigating the structured programming world with ease. Remember, understanding structured programming is like unlocking a new level in the game of programming. So keep practicing, keep learning, and you'll surely master it.